Have you ever seen a flash of lightning split the sky, lighting up the world for just a moment, as if nature itself is putting on a spectacular show? Or maybe you've heard the booming thunder that follows, rumbling through the air and making windows shake. These moments can be both thrilling and a little bit scary, reminding us just how powerful our planet can be. Or have you ever felt the ground tremble beneath your feet, as if the earth itself is moving? Earthquakes can happen suddenly, turning an ordinary day into an unforgettable experience. The shaking can be surprising, but it's all part of the incredible forces at work beneath our feet. Lightning and earthquakes are some of nature's most powerful forces, capable of changing landscapes and shaping the world we live in. They remind us that our planet is alive, dynamic, and always in motion. These events might seem scary at first, but the more we learn about them, the less frightening they become. Understanding what's happening helps us feel more confident and prepared, turning fear into curiosity. Science lets us peek behind the curtain and see how these amazing events work. Scientists study storms and earthquakes to unlock their secrets, using special tools and experiments to figure out what causes them and how we can predict or prepare for them. Knowing what to do during a thunderstorm or earthquake is like having a superpower. With the right knowledge, you can stay safe and even help others around you. Practicing safety drills and learning emergency tips gives you the confidence to face these forces head-on. On this journey, we'll explore the science behind lightning and earthquakes, how they happen, why they matter, and how we can stay safe. We'll visit classrooms, meet scientists, and see real-life examples of these forces in action. We'll discover the tiny particles inside storm clouds that create lightning, and watch as electricity leaps through the sky in a dazzling display. You'll learn how storms build up energy and release it in a flash. And we'll dive deep underground to see the massive plates that make up the Earth's crust, moving slowly but powerfully. When these plates shift, they can cause earthquakes that shake cities and reshape the land. Our planet is alive with energy and change, from the clouds above to the rocks below. Every thunderstorm and earthquake is a reminder of the incredible forces that shape our world. By learning about these forces, we see that they're not random chaos, but fascinating science at work. There are patterns, reasons, and explanations behind every rumble and flash. So, get ready for an electrifying, ground-shaking adventure. Together, we'll uncover the mysteries of lightning and earthquakes and discover how science helps us understand and respect the power of nature. Let's dive in. Science rules. What is lightning? It's one of nature's most breathtaking and mysterious phenomena, a force that has fascinated humans for centuries. But what exactly is happening when we see those brilliant flashes in the sky? Lightning is nature's electricity, created inside massive storm clouds known as cumulonimbus clouds. These clouds can tower miles into the sky, forming during powerful thunderstorms and carrying enormous amounts of energy. Deep inside these clouds, tiny ice crystals and water droplets swirl around, colliding and rubbing against each other as strong winds toss them about. This constant movement causes static electricity to build up, just like when you shuffle your feet on a carpet and then touch a doorknob, feeling a small shock. As these particles interact, they separate into positive and negative charges. The cloud becomes like a giant battery, storing up electrical energy and waiting for the right moment to release it. Negative charges gather at the bottom of the cloud, while positive charges collect at the top. The ground below, in response, becomes positively charged as well, setting the stage for a dramatic electrical showdown. As the difference in charge grows stronger, the air between the cloud and the ground acts like an invisible barrier, resisting the flow of electricity. But eventually, the electrical tension becomes too great, and the air's resistance breaks down. A narrow, invisible path of ionized air forms, connecting the cloud and the ground. When this path is complete, a powerful surge of electricity races through it, zap, and a brilliant bolt of lightning lights up the sky, sometimes branching in spectacular patterns. That bolt of lightning is incredibly hot hotter even than the surface of the sun. It heats the air around it in an instant, causing the air to expand explosively. This rapid expansion creates the rumbling sound we know as thunder. We always see lightning before we hear thunder because light travels much faster than sound. The flash reaches our eyes almost instantly, while the sound of thunder takes longer to arrive. Lightning is a powerful, spectacular, and dangerous burst of static electricity. It reminds us of the incredible forces at work in our atmosphere and the beauty and danger of nature's raw power. How do we protect tall buildings from lightning? With a simple invention, the lightning rod. Think of it as a superhero for buildings, guiding lightning safely into the ground. The rod, usually copper, sits at the highest point and attracts lightning. A thick conductor cable connects the rod to a ground rod buried deep in the earth. When lightning strikes, the electricity travels down the cable and disperses harmlessly into the soil. This system keeps buildings safe from fires and damage. It's a clever way to control nature's power. Thanks to lightning rods, our tallest structures can stand strong, even in the wildest storms. Simple science, big protection. Now let's look beneath our feet and discover what's really happening deep inside the earth. Most of us walk around every day without thinking about the ground below, but there's a whole world of activity happening under the surface that we can't see. The Earth's surface is made of huge, rigid pieces called tectonic plates. These plates fit together like a giant jigsaw puzzle, slowly drifting atop the hot, flowing mantle beneath them. Over millions of years, their movement shapes continents, forms mountains, and even creates deep ocean trenches. Sometimes, the edges of these plates get stuck against each other, unable to move freely. As the plates continue to push and pull, stress and pressure build up along these boundaries, especially at places called fault lines. This tension can last for years, decades, or even centuries. When the pressure finally becomes too great, the plates suddenly slip or break free. This rapid movement releases a burst of energy in the form of seismic waves, which travel through the ground in all directions. It's this sudden release that causes the earth to shake. That's what we feel as an earthquake, a powerful jolt or series of shakes that can move buildings, trees, and even entire landscapes. Sometimes the shaking is gentle and barely noticeable, but other times it can be strong enough to cause serious damage. The spot deep underground where the plates first slip is called the focus, or hypocentre. Directly above it, on the Earth's surface, is the epicentre, the point where the shaking is usually felt the strongest. Seismic waves ripple outward from the focus, shaking the ground as they travel. These waves can move quickly, spreading the effects of the earthquake far from where it started. The closer you are to the epicenter, the stronger and more intense the shaking will feel. That's why some areas experience more damage than others, even during the same earthquake. Earthquakes are simply the Earth's way of releasing built-up stress and tension. They can reshape the land, create new cracks or faults, and even change the course of rivers. These powerful events remind us that our planet is always moving and changing, even if we can't always see it happening. Over time, earthquakes help build mountains, form valleys, and shape the world we live in. By understanding how earthquakes work, we can better prepare for them, protect our communities, and stay safe when the ground starts to shake. Knowledge is our best tool for living on this ever-changing planet. How do scientists measure earthquakes? With a seismograph, a device that records ground motion. When the ground shakes, a suspended weight stays still while the frame moves, drawing zigzag lines called seismograms. The bigger the wiggles, the stronger the quake. Networks of seismographs help pinpoint where earthquakes start. To measure strength, scientists use the Richter scale, a logarithmic scale where each number means 10 times more shaking. A magnitude 6 quake shakes 10 times more than a 5. Major quakes, 7 or higher, can cause serious damage. Today, scientists often use the moment magnitude scale for accuracy, but the idea is the same. These tools help us understand and compare earthquakes worldwide. Knowing lightning science is cool, but safety comes first. Rule 1. When thunder roars, go indoors. If you hear thunder, you're close enough to be struck. The safest places are sturdy buildings or hard-topped cars. Once inside, avoid using corded electronics and stay away from water. Lightning can travel through wires and pipes. Stay clear of windows and concrete walls. If you're caught outside, avoid open fields, hilltops, and tall objects like lone trees. Stay away from water. Crouch low with feet together and cover your ears. Don't lie flat. Minimize contact with the ground. Being prepared and following these rules keeps you safe until the storm passes. Earthquakes strike without warning, so practice is key. The best safety move is drop, cover, and hold on. Drop to your hands and knees to avoid being knocked over. Take cover under a sturdy table or desk, or protect your head and neck with your arms. Stay away from windows and tall furniture. Hold on to your shelter. It might move during the shaking. Stay put until the shaking stops, then wait a moment for aftershocks. Don't run outside. Most injuries happen from falling objects. Practicing these steps can save lives during an earthquake. Lightning and earthquakes aren't just random events. They're science in action. Understanding them helps us make smart, safe choices. Knowing why you avoid trees in storms or take cover during quakes is life-saving knowledge. Sharing what you learn builds safer communities. Science inspires new ways to predict and protect against natural disasters. Your curiosity today could lead to tomorrow's innovations. Science replaces fear with respect and preparedness. Our planet is powerful, but we can coexist safely by understanding it. Stay curious, stay prepared, and help others do the same. Science is everywhere, in every smart choice you make. We've explored the science behind lightning and earthquakes and learned how to stay safe. Knowledge turns fear into preparedness. Now you know what's happening, why, and how to protect yourself. Remember, when thunder roars, go indoors. Drop, cover, and hold on. Share these tips with family and friends. Help your community be ready. You can be a leader in safety and science. Next time you see lightning or feel a tremor, remember the science and follow the rules. Appreciate the power and beauty of our planet. Stay curious, keep learning, and make safe choices. Science is your superpower. Never stop exploring.